Okay, good morning students. So last class lo manam thermal properties of matter, so that topic already discussed in last class. Today discuss the another topic, the another chapter, so thermodynamics. Okay, so thermodynamics, very important role in a physics. So already in a lower class lo studying thermodynamics, so thermal properties, so already discussed in a lower classes. Now today discuss the thermodynamics, the first law, and thermodynamics second law. Okay, so etc. prepare today. So thermodynamics first law that is the dq is equal to du plus dw. Okay, thermodynamics first law we can write dq is equal du plus dw. So the energy, the heat is required to the system. The heat is required to the system is utilized or increasing of the internal energy. Internal energy, and so some doing work done by the system. Okay, so some doing work done by the system. So that is called as a thermodynamics first law. So the heat is, okay, so the amount of heat is supplied to the system, so that the heat is utilized, so increasing of the or so developing of the internal energy or temperature, that is the du. And so some doing work done by the system is dw. So that is called as a thermodynamic first law. So thermodynamic, according to based on thermodynamic first law, so here taken there is the dq. So the dq, the amount of supply heat, the amount of heat supplied to the system, to the body, and so developing or utilized to one of the part, so that is the du. So du means developing of the internal energy, and so the dw is nothing but so some doing work done by the system. Okay, so that is called as a thermodynamics first law. So dq is equal to du plus dw. dq is equal du plus dw. Right. Now, so here the dq amount of the heat is supplied, that is increasing internal energy, some doing work done. Got it? Some doing work done. And is also that is the thermodynamics first law is consequency. So just like law of conservation of energy. Okay, and so sign convention is taken. So sign convention, so that is dw is taken positive. Okay, dw is taken positive. So the amount, that is the so the work done by the system. Okay, so the dw, that is the sign convention. So sign convention, so that is the plus the dw, so positive work done. So positive work done, that means work done by the system, minus dw, work done on the system, and so plus dq. So plus dq means so the amount of the heat is supplied to the system. Okay, so the amount of heat supplied to the system, and minus dq. So minus dq means so the amount of the heat is taken out from the system. The amount of the heat is taken out from the system, that is the minus dq. Okay, so plus dw, the amount of the, and that is means so the positive work done by the system, and minus dw. Minus dw means work done on the system. So plus dq means so the amount of the heat is supplied to the or required to the system. Okay, so now once again another taken minus the dq. So minus dq means the amount of the heat is taken out from the system, right? So now also the thermodynamics first law conditions are. So the condition, first condition or limitation, first limitation is taken. The quantity of the heat flow, so it is did not explain. Okay, it cannot explain. So the thermodynamics first law cannot explain the heat flow of direction. The heat flow direction. So anyway, any direction is also possible of the heat flow, but it is does not explain direction of the heat flow. Okay, thermodynamics first law. So the direction of the heat flow, it is could not explain. And also, so it is does not explain of the efficiency. Okay, that means the amount of the energy is required to the system. The energy is required to the system. Does not or it is cannot complete totally work done. Okay, just for example, the electric energy is supplied to the pan. So the pan is complete work done, mechanical work done. And also is some heat is supplied. It does not complete 100% work done. Okay, got it? Right. So if for example the tube light is taken, so the energy is the electrical power energy is supplied to the tube light. So the some amount of the energy is utilized to light. Some energy is utilized to heat. That means so 100 it does not work 100% efficiency. 100% efficiency. So that is called as a limitations of the thermodynamics first law. Okay, got it. So it does not explain the direction of the flow of heat, and it does not explain the efficiency. Okay, great. So now discuss the another topic is Cp and Cv. Cp and Cv. Molar specific heat capacity at constant pressure. Molar heat capacity at a constant volume. That means, so Cp means, so molar specific heat capacity at a constant pressure. Molar specific heat capacity at a constant volume. Okay, so the amount of the heat is required to the system. Okay, the amount of the heat is required to the system. Okay, so the amount of the heat is required to the system and increasing of the temperature. Increasing of the temperature. So mole of the gas through 1 degree. Through 1 degree at a constant pressure is called as a molar specific heat capacity. Molar specific heat capacity. Okay. So what mean of the molar specific heat capacity? So molar specific heat capacity, so the amount of the heat is supplied to the system, that is increasing of the temperature. So molar, 1 mole of the gas through 1 degree. Through 1 degree. At a constant pressure, so that is called as a molar specific heat capacity. Molar specific heat capacity. Right. So according to the definition of the molar specific heat capacity, so Cp is equal 1 mu dq by dt. dq by dt. So mu means number of moles is taken. Number of moles. So Cp is equal to 1 by mu dq by dt. Got it? So now another definition is taken, Cv. So Cv means molar specific heat capacity at a constant volume. Okay, so according to the definition, so the amount of the heat is required to the system, the temperature is increases. 1 mole of the gas through 1 degree at a constant volume, so that is called as a Cv. So Cv, you can write the mathematical form, so 1 by mu dq by dt. 1 by mu dq by dt. So molar specific heat capacity at a constant pressure and molar specific heat capacity at a constant volume. Now, so one other discuss that is, so which is better, Cp or greater than Cv or Cv is greater than Cp. So generally, so Cp is greater than Cv. Now prove that. Okay, so Cp means molar specific heat capacity at a constant pressure. Here taken at a constant volume. That means, so the amount of the heat is required to the system, the amount of the heat is supplied to the system is increasing the temperature. It no spent of the expansion. Okay, no spent of the expansion. That means only is utilized to increasing of the internal energy. Internal energy. So now so the total amount of the heat is supplied to the system, that is complete used to only internal energy developed. Internal energy developing. That means so the amount of the heat is supplied to the system, that is the dq is equal d2 plus dw according to the definition of the thermodynamics first law. But so dq is equal to du we can write, because so at a constant volume, so that is no expansion, no spent of the expansion, only utilize the increasing of the internal energy developing. Okay, right. So now another pattern. So same phenomena here apply. Okay, so Cp means molar specific heat capacity at a constant pressure. Okay, got it. So the amount of the heat is supplied to the system, and here, okay, used to increasing of the internal energy or temperature, and also doing some work done. That means so here, so energy is supplied to the system, that is completely used to two parts. That is one of that is the temperature is increasing. That means internal energy is also developed, and some amount of doing work done by the system against the pressure. So that is called as a Cp. Okay, and that means so Cp, so the amount of the heat is supplied to the system is compared to the more than dq. So that means Cv, because so the Cp is utilized to increasing internal energy, some doing work done. That means so Cp is more energy is required compared to the Cv. Okay, so that big condition we can write, so Cp is greater than Cv. Cp is greater than Cv. Okay, got it. Only Cv. So Cv only utilized to increasing of the temperature. That means internal energy is developed. No spent of the expansion, no doing work done. Okay, clear that. But here, so internal energy is developed in a Cp, and so some amount of doing work done by the system. Okay, but in this conclusion, so Cp is greater than Cv. Got it. So now discuss the another topic in a next class. Okay, thank you students.